All right, so the next step, these types of problems are a little bit different, so we need to take it into two different steps. We're going to be looking at before a collision and after a collision and trying to see if momentum is conserved. So the problem that we're looking at here, it says a 10,000 kilogram railroad car is traveling at 3 meters per second when it strikes another 5,000 kilogram rail car that is at rest. The cars lock together and travel at 2 meters per second. Was momentum conserved? So the first thing we need to ask ourselves is this collision elastic or is it inelastic? In this case, we can see that the cars lock together, so it has to be an inelastic collision. So the first thing that we're going to do is draw us a little picture. So before the collision, we know that rail car 1 is traveling at 3 meters per second, and rail car 2 is at rest. After the collision, we know that both of the rail cars lock together because it's in an elastic collision, and they're traveling at 2 meters per second. All right, so that's step one. Now the next thing we need to do is find out what the total momentum of the system is before the collision takes place. In order to do that, we need to figure out what the momentum is of object 1 and object 2. So the momentum of rail car 1 is equal to the mass times the velocity of that rail car. So momentum is equal to the mass, which is 10,000 kilograms, times 3 meters per second. And we get a momentum of rail car 1 of 30,000 kilograms meters per second. All right, so that's rail car 1. So now we got to look at rail car 2. So that's mass 2 times velocity 2. So we can see that our mass of rail car 2 is 5,000 kilograms, and we know that it's at rest, so that means that it has 0 velocity. So something that has 0 velocity, we know has to have 0 momentum. So we can just show this, 5,000 times 0. Momentum has to be 0 kilograms meters per second. So in order to find our total momentum, we need to add the momentum of object 1 plus the momentum of object 2. So total momentum is equal to 30,000 plus 0, and we get a total momentum of 30,000 kilograms meters per second. All right, so that is our momentum of before the collision. So now we need to look at our momentum after the collision takes place. So first things first, we know that it is an inelastic collision. So that means that our masses are sticking together. So that means that we need to add those masses together. So we need to figure out our total mass. And that's mass 1 plus mass 2. So total mass is equal to mass 1, which is 10,000 kilograms, plus mass 2, which is 5,000 kilograms, and we get a total mass of 15,000 kilograms. So now we know our total mass. In our problem, we know that they are traveling at 2 meters per second after the collision, so we know our total velocity. We can figure out our total momentum. So our total momentum is equal to our total mass times our total velocity. Total momentum is equal to 15,000 kilograms times 2 meters per second. And we see that our total momentum in this case is 30,000 kilograms meters per second. And since our initial total momentum is equal to our final total momentum, we can say that momentum was conserved in this collision.